This presentation speaks to how to gas trace a variable air volume fume hood. It explains what a gas trace is and why a gas trace test is necessary. Variable air volume fume hoods at the time of initial installation require two extra tests to be done: VAV response and stability test / movement containment test. Existing fume hoods require the test to be done every 5 years. Gas trace test variable air volume fume hoods are as described in Public Works Government Services document MD 15128, which was made in 2008. It's a document and a guidelines what must be done for government laboratories in buildings of all sorts, especially government buildings. If it is not a government laboratory, then you use the ASHRAE 110 set of guidelines. VAV response and stability test. Dynamic VAV response and stability tests are conducted to ensure that the VAV controls meet the required criteria over a range of operating modes as described in document MD 15128, Table 1, 2008. The tests consist of a measurement of flow while raising and lowering the sash at an approximate rate of 0.5 meters per second, or following a change in operating mode. The VAV tests consist of a 5-minute flow response test and two 5-minute flow stability tests. The flow response test is conducted by recording slot velocity while raising and lowering the sash 3 times in a 5-minute period. The sash is raised and lowered smoothly at a rate of 0.5 meters per second. The sash is in the closed position for 30 seconds, then at the design operating height for 60 seconds during each of 3 cycles. The flow stability test is conducted with the sash closed for 5 minutes and open to the design operating height for 5 minutes. The stability tests determine the ability of the VAV controls to maintain stable flow at the minimum flow set point and to maintain the flow required to achieve the specified average face velocity at the design operating height and any other height. To perform this test, the below-listed equipment is required: a test cart, a laptop computer, a flow sensor in exhaust duct near the damper actuator, velocity probe measuring slot velocity in fume hood. The response and stability tests can be conducted by measuring exhaust flow directly using a flow sensor mounted in the duct, or by measuring the fume hood slot velocity. Using slot velocity, flow response is determined by placing the tip of the velocity probe in the slot behind the baffle, where changes in slot velocity are directly proportional to the changes in flow. The velocity probe is mounted in a secure stand with the probe located in the center of the baffle slot opening. The velocity probe can be oriented to measure air velocity entering the slot, or it can protrude through the slot to measure vertical plenum velocity. Slot velocity or flow is recorded at a rate of at least 1 sample per second using a data acquisition system or data logger while raising and lowering the sash. Sash movement containment. Tests for trace gas test variable air volume flow hood. The sash movement containment test is conducted to determine the potential for escape of contaminants from the hood following the movement of the sash. To perform this gas trace test, the below listed equipment is required: a test cart, a mannequin, a laptop computer, a detector, which is a sensor at the mannequin nose, and a gas ejector. The fume hood will be complete with a variable air volume control system. The mannequin is placed at the center of the hood opening, while tracer gas is generated through an ejector located in the hood in front of the mannequin. As in the VAV response test, the sash is raised to design operating height and lowered 3 times at a rate of approximately 0.5 meters per second. The sash is closed to 30 seconds and open for 60 seconds during each of 3 cycles. Tracer gas is measured using an appropriate detector and recorded at a rate of 1 reading per second using a data acquisition logger. Data is analyzed to determine the 5-minute average and maximum concentration in parts per million escaping the hood. Note: for VAV fume hoods, the VAV response and stability tests and the sash movement containment test can be conducted at the same time. This will save some time and provide a correlation between flow variations and gas escape from the hood. Acceptable results for GasTrace VAV fume hood tests with sash heights at 660 millimeters and 450 millimeters, done at the manufacturer's facility. At peak, as manufactured, cannot be greater than 0.10 part per million. The 5-minute average cannot be greater than 0.05 parts per million. As installed, sash movement effect at peak cannot be greater than 0.10 parts per million. 5-minute average cannot be greater than 0.05 parts per million as used. Sash movement effect at peak cannot be greater than 0.10 parts per million. 5-minute average cannot be greater than 0.05 parts per million. I hope this helped your understanding of how to test a variable air volume fume hood. Thank you for listening. Bye now.